That stage is prototyping. It's a very crucial phase of this. So, this is the agenda for today in my session. So let's look at the first piece, research and analysis, right? So what we are doing today is let's do a quick exercise on how you would research or how would you understand the market for your product, right? So the first step is understanding the market. Now, when we talk about understanding the market, what I want you guys to do is all of you sitting over here have a mental image or have probably some of you all have a physical image of the product or the platform or anything in hardware that you have already developed selling to something, right? So you have a problem in mind. What is that problem statement? So let's make a quick assessment. If you guys have pen, paper, notes, we have a lot of post-its. You guys can come and stick up your notes over here. This is an interactive session. It's a workshop, so please feel free to write down things. So I request you guys to write down what is the problem statement that you're trying to solve. Is it if it's a platform, if it's a product, it could be anything. If you guys have notes, please I request you to write it down. What is the problem statement you guys are solving? We have a bunch of sticky notes here. I request you guys to please step up. This is more likely to give you a lot of clarity as to how this whole thing is going to go on. It works even if you write it down on your phones as well. So you can start typing on your notes. If you are defining a problem statement, let's start with simple. It could be a one-liner, need not be anything bigger than that. So I'd probably give you a minute to figure out and write out what is the problem statement you are trying to solve as a hardware product or as a hardware platform, right? So let's see and figure out how the session goes. You all have something in mind? Feel free to speak up. If you have any questions, you can ask. There is no essential Q&A session or anything. It's just a networking session afterwards. We can work dynamically on this. You guys have queries or questions about what I'm asking or what you're thinking. Is it in the same line? You guys can feel free to interact. I may even take up examples, right? So, for example, if I have to take a simple example of a product segment, I want to build invisible earphones. That could be a product that I'm building. And the problem statement I would hypothetically try to solve is earphones look ugly no matter how good they're designed. So I want to make something invisible. It's a problem statement. So if that's the problem statement, right? What do you do to understand the market? Is I would like you to imagine 5 places, right? I would like you to imagine 5 places where this problem statement exists. I'll go again. I would like you to imagine 5 places where this problem statement exists. It could be a physical place like a store, a club, a school, or a university, or a football field. It could be a physical place. It could be a digital place like a place like Amazon, Flipkart, or let's say it could be a digital space. It could be a virtual space like NFT tokens, or let's say even crypto. It could be a virtual space as well. Think of 5 places that your problem statement exists today, right? 5 places, right? If you're thinking of places like offices, schools, showrooms, clubs, it could be anywhere. Think of 5 places that the problem statement exists in any form, right? Solved or unsolved exists in any form. 5 places, right? Let's give it about a minute. Think of 5 places. If you guys have written anything, you can stick it up over here. I'll quickly draw a marker line. So this is part of like this. 5 places, right? So if you guys have written one, so you guys can come and stick it up here. I'll collect it. Let me know. You guys want to, instead of skipping writing all of that, you guys want to write directly over there. Maybe some of you have already thought and you may have overlapping thoughts, right? Like if you've thought about offices or a home office, right? Since a lot of people work from home now, home office could be a place which is common for everybody. Not sure what is the product or platform you have in mind. It could be anything. There exists at least 5 places, I believe, for any state, any problem statement, right? Could be hospitals, it could be, let's say, media companies, it could be anything. Any 5 places that it exists in. Right. We can always revisit. It's a working session, so you guys can rewrite, come back and rewrite. Once you have written down or identified, let's say, 5 places, what we're going to do next is I want you to imagine today, if I go there, right? If I go there without knowing anything, today, what are, let's say, 5 products, platforms, or solutions that I find in each of these 5 places, right? 5 solutions, right? Right. So if I have to go back to my hypothetical example of building an invisible earphone, I would write 5 places as, let's say, Amazon, Reliance Digital, Apple Store. These are the places where the problem exists. When somebody's trying to buy, you're looking at it, it's not so nice. No, somebody comes and says, hey, invisible earphone, if you had, I would buy immediately. So it's a hypothetical problem, hypothetical place. Those are the 5 places. Now, if you go to the 5 places today, what are the 5 solutions that exist for your problem statement? You all have written the problem statement, you have identified 5 places. What are the solutions that exist today? Okay, it could be half solving the problem, it could be nowhere close to the problem, it could be completely solving the problem, it could be anything, right? What's the first 5 things that comes to your mind? And what are the first 5 things that I would see as a layman if I go there? Right? If I go to Reliance Digital, the first thing I see is either Sony, Samsung, or Panasonic, which is broadly displayed out there. Right? I wouldn't probably see new upcoming startup platform somewhere. Maybe Boat nowadays has picked up, so since they've picked up a lot of branding, you may see that as well. So just imagine as a layman, what are the solutions that would exist in today's scenario? And that's a very, it could be a very arbitrary answer. You don't have to rely really on. Some of you might have done research, you might have actually gone through a lot of research papers, articles, or maybe McKinsey articles to find out your problem statements. But right now, let's get into the founder mode and see, hey, grassroots, what is the solution and the problem at the 5 places that we are looking. If I go there, what do I find today? Right? Anybody having any thoughts or confusions or clarity as to where this is going and why this is happening, or what I'm telling? Does it even make sense? Anybody is confused or thinking?
Can I write one?
Yeah,
We have identified a place.
Yes, you can write. Put up a sticky note, you can write. Feel free to do that. This is all part of understanding the market and analyzing the competition. So, considering the fact that now you have identified places, you have identified existing solutions, right? It's the next natural question or the next natural action would be: have you all personally ever had the chance to go to these places, try these solutions? Could be yes, no, maybe, doesn't exist. Either way, have you personally had the chance to go to these places, try these solutions? Question number 1. That's for you to answer for yourself. You need not put up or write it down. Once you go to these places, have you tried these solutions? That is again a binary answer. Yes, no. If you've tried these solutions, have you gone to these places and tried to sell the same existing solutions to the customers? Like for example, if I had to make this, have I gone to Reliance Digital, tried to sell an AirPods or a piece of earphones to someone who's buying? That is when I would know if someone really needs an invisible earphone or not. If I ask a bunch of 100 people, they'll say everybody needs it. But if I try to really sell this in a store like Reliance Digital, that's when I'll really find out if somebody has asked for it, do they need it, at what cost or price do they need it, when do they need it, all of those things you will find out once you get to that stage. So my question to you guys is, out of these 5 places and these 5 solutions, have you got the chance to use it, try it? Best if you've got the chance to sell it. Have you gone to a place, try to sell a competitive product or an existing product? That's the question. At least have you tried to speak to somebody? Like, hey, here is a product that I have. Are you interested? Or, it could be Amazon or it could be Flipkart. Like I asked you to imagine these places, right? So if you are selling, let's say, a football that never has to be refilled with air, and you're in a sports stadium and you're trying to sell, right? Have you been in that situation? Have you put yourself at a place where you're trying to make an understanding of customer requirement versus your product feature? Now, why again this is important, you may ask? It's quite important because initially we said, hey, write down a problem statement. That's where we started saying, hey, write down a problem statement. Now, that problem statement exists in our minds as we are founders, the creators, it exists in our minds. What happens when that problem statement is dead opposite from what the customer wants? When you go to a store and try to sell, you'll figure out whether your problem statement is in the same circle, it's in a complete different circle, or is it overlapping and you have solved half of the problem or not. That is very crucial to understand because you are then trying to understand whatever your calibration is regarding the problem statement. Is it even matching the client's problem statement or potential customer's problem statement? So that is the reason why I asked this mental exercise to be done is so that you keep doing this exercise every once in a while. If possible physically, otherwise at least virtually in your mind, right? Write down, try, exercise, or go physically and try. If you have the, let's say, luxury, if you're selling an aeroplane, that's definitely difficult to do, right? I wouldn't go to, let's say, an airport or a company and say like, hey, I have a new sort of product. That's not very straightforward or easy to do, but I'm talking about simpler, smaller products if you have. That's probably possible. So you guys can, I encourage you guys to keep trying this exercise that gives you a overlap of your problem statement in your mind versus problem statement in customer's mind. Right? Then that brings us to the documentation piece. So once you write down saying that, hey, this is the problem statement that I have in mind, this is the problem statement that the customer has in mind, then you have a complete understanding of what you're solving. Right. So this is a bit of deep dive into the each segment. What this does is, if you try to go to these places or figure out your understand the market, you're validating a problem statement. You're even identifying is it big enough or not. What are the current solutions and what are the developments in the existing industry? What are the customer pain points? Who is the customer? And what solutions are they currently using? Right? You easily understand and document this. Then there's a research methodology. Now, once you understand your problem is same or different or wide, there's primary research, secondary research, talking to customers. You can buy research reports. You can ask a set of guys to do it. It's a simple online poll, LinkedIn poll, web poll. You can even host a complete event in a bar and say, hey, this is my problem, this is my statement, this is the thing. You can always interact with a lot of people and figure out what's happening. Then how do you analyze the competition? Yes, of course. Starting with the problem, you understand. Once you try to sell their products, they will tell this is too expensive, this is too big, this is too ugly. Can I get this in like a color which changes every day? Whatever, right? You understand the problem when you start selling existing products. That's what customers will start asking. What do the customers think? Study the product offerings and understand what they think about the products. This is again a derivative of what I just said. If somebody is trying to sell an aeroplane, they're like, I wanted to go to sea also. So those are the kind of things that probably you will get asked, and the extremities also exist. Once you find out all of this, it's a very simple documentation. You can use good set of tools. There's a lot of online tools available to document your findings. You do a complete product management journey. You have repositories. You have existing frameworks where you can put these points and figure out a way to solve your problem. So this completes our section where we are doing the sorry for that. Okay, so this completes the section where we are doing the market research. Now, once we are all set and understand, that hey, yes, this problem exists, this solution needs to be there. These are the features that we need to go. Let's get into ideation. This ideation is the phase where we all are excited. It keeps us up awake at night. So, what is ideation? The first part of ideation is collaborative brainstorming. All of us here have probably spoken about this idea to someone, right? Friends, families, people, colleagues, customers, random people. You guys have probably spoken about it to somebody. And that would lead to some amount of discussion, right? So if you're in an office setting, or if you're in a social event or a workshop like this, you start collaboratively brainstorming. Then you start understanding the feasibility and you start filtering the feasibility, right? So, for example, if I had to make the earphone invisible again, is it really feasible, right? At what cost? Nothing made a earphone that looks complete, almost transparent and it's got all sorts of visibility. So what is the feasibility of doing it? Is cost associated with it, timeline associated with it, people associated with it. Whatever the feasibility is, you start filtering that. Then you start prioritizing features, right? There's a couple of frameworks that I will show you today to start prioritizing features. These frameworks are essentially for you to sit down and evaluate and get a set of feedback from people with let's say value, effort, efficiency, confidence, and so on. Some of them are subjective methods, some of them are objective methods. I'll get into that as well. Once you prioritize these features, you have a complete framework of what your idea is and how the solution looks like. Right? So how do we go about brainstorming? So brainstorming, sometimes it seems very easy. You go on, write, scribble, hit a dead wall, sleep, come back again. But the best way to do it is to put a team together. When you put a team together, you have to try to be as dynamic as possible. Try to get everybody, right? Some of you might have worked with corporates before, some of you might have worked with large organizations where, for any product launch, there's a marketing team, there's a sales team, there's an operations team, there's a production team, there's a management team, there's all sorts of teams. But as, let's say, early founders, you basically start with friends, families, and people who think alike, especially people who think the opposite way. Right? Like if I say this product has to be cheap, somebody will come and say, no, that has to be expensive. So you get a set of people who think in all directions, and that allows you to explore different perspectives for the same problem that everybody has. So gathering a team is very crucial. Then on a small workshop, right? It could be a weekend thing or over a breakfast, or it could be a formal event, it could be a poll, it could be a live session, it could be anything, but run something by people. Like talk to people and understand, hey, this is an idea in this direction, this is what we have put together. Talk to people and find out that your problem statement is getting solved by XYZ methods and what's efficient and what's not. So that is a very important part. Then comes the collaboration. So if you have access to platforms like Miro, Figma, these are free platforms. Go to those platforms and write down everything. So if you have a team of 5 people and let's say sales team says this, production team says this, and let's say design team says this, you put everything on a platform and try to get a complete visualization of what your situation is. Now at the end of this brainstorming, what do you expect, right? What do you expect? You expect to put together sort of a understanding as to what your costs might look like, what your physical form factor might look like if you're building something, right? If you're building something, it should be round, square, tall, broad, thin, whatever it is, you have physical existence to it since you're talking about hardware. You get an idea of what that needs to be. Then, how do you go about filtering feasibility? So there are a few types of feasibility. One is cost feasibility, then there is technical feasibility. Let's say you are building, again, an invisible airport. It is not feasible to build on because some material exists. People are going to see, and even if it's transparent glass, people are going to see it. It cannot truly be invisible. So, at what barrier do you say, hey, it's feasible, right? And at what cost is it feasible, right? Does it immediately change to the tone of your skin, then it becomes invisible? At what cost are you going to make it, right? How feasible it is? Are you going to spend 10 years of research development, develop custom materials and make it happen? Maybe, may not be. That's the technical feasibility versus cost feasibility. Then market viable. Is it a real problem? Have enough people asked for it? Is it a real problem? And what is the willingness to pay? Is someone going to pay a lot of money for it or not? What is it? What is it really count for? And what are the current trends and future projections? Right? Is there a way to circumvent the entire problem statement and give a solution which masks the product statement in certain way, right? Instead of really solving it. Then the most important thing is, does it align with the company? Now, all of you are in some way trying to figure out what the existence is. Let's say as a brand, as a product, as a company. Does it align with the company? I could give a simple example. Company vision usually works around certain keywords or factors. Like for example, if I were to take an example of Maruti Suzuki, the company values economy, over everything else, right? Over comfort, everything else. It values economy. So any product that they build, whether it's the engine, clutch, vehicle, anything they build, they will think of economy. Does it make sense? Is it cheap? Is it going to give the mileage? What does the customer want? They want economy. Versus a company in the same sector like Bentley. Bentley will not care about economy. They'll be like, is it luxurious? Doesn't matter what the price is. It aligns with the company's value. And it means luxury, right? Anything you touch inside of a Bentley is made out of metal and aluminum and leather. So it's all, it speaks with that. So anything they design, anything they touch, anything they talk about is going to align with the company's value. So when they start looking at feasibility, right, they will not look at things that are, in a complete bracket. They will be able to filter it because it aligns with the company values. Right? There's no point in market trying to figure out full complete leather interiors because it doesn't align with the value of the company. Though somebody might have asked, maybe customers ask, but it may really not align with the value of the company. The third point was prioritizing features, and as I mentioned, there are a few frameworks. This is one of the more subjective frameworks, right? Let's say you as a part, you as an individual, or if you're part of a team, gather everybody and put this now. So you have, let's say, 10 features you want in your product, okay? Never have to charge this, it has to be visible, it has to be small, it has to fit in pocket, whatever your features are. Put a value versus effort graph. This is a very straightforward graph. Anybody would be able to imagine and understand it. This bit is high value, low effort. Okay? So if your feature is, let's say, offer more colors in your product, it's of high value and low effort, it's an easy thing. Go for it. These set of features that you post are very easy to build, okay, and are very, very high value. It's an easy decision, build it. Next is this side, which is low value, low effort, which means you give them as incremental. Maybe version 1, version 2, version 3, like if you've seen all sorts of phones, right? Phones build version phone 1, phone 2, phone 3, phone 4. They build incremental features, and those features are mostly in this area, where it's low effort, low value, but it gives some amount of incremental advantage. Then there are the big bets, which are high value, high effort, right? Like extremely high value, it requires a lot of effort, which, like I said, something that changes the color as per your skin tone. So that's extremely high value, extremely high effort. Those are the big bets. Chasing this, you may win, you may lose. Those are the big bets. You got to take a very educated call on it. Involves cost, involves resources, involves all of that. It's a very important call. Then these are money bets, which is extremely high effort and very low in value. Right? Like if I have to give an example of this one, it kind of does not have any form factor. It's just completely invisible. So that's extremely high effort, very less value, but it's a money pit, right? You keep pouring a lot of time and effort and resources into that one particular feature, and even if it makes it to the market, it's a very low one. So you can keep this aside. Your top section is something that you can immediately start. Easy wins is just low value, high effort, and high value, high effort. These are the sections that you can look at. So this is a very subjective way of looking at prioritizing. Another method is called RICE framework. In this particular method, what you do is this is extremely objective. You've got to put numbers. It's a mathematical method and a mathematical way of calculating which features are important for you. Okay. The example here we have taken is of a purchasing platform, which is, let's say, involving some sort of integration in payments and authentication. So this is a very simple example. Okay. That particular example involves 4 features. Biometric authentication is feature number 1. Then Stripe Pay integration, Shopify e-commerce card, and API dashboard. So in this kind of a situation, you go with reach, impact, confidence, and effort. That is RICE. So what you do in reach is you understand what's the reach of your let's say feature. So if you added biometric authentication, your reach would be, let's say, 81 people or something like that. And then what is the impact of it? Out of a score of 5, what is the impact of that feature? Then what is your confidence in building the feature? Right? Is it something new? Is it something nobody has done? Is it something that only you can do? What is your confidence in building that feature? It could be your own confidence, your own team, or you've spoken to someone, somebody is able to outsource it. That's something that gets you the confidence, and it also depends on how much time you've spent around So this confidence is a great number, and then the effort. For you, it may be very easy. For if you put up a team, it may be easier, but for someone else, it may be difficult. So this is again to be evaluated by the person. So if you multiply all of this, this is the way you will, let's say, get the score. Reach it to impact into confidence divided by the effort number will give you the score. Right? You do this for all the features. Eventually, the one that is your top one or two features is something that you can go lightly with. That means that you're with minimal effort, you are giving a maximum number of features, impact, and reach. Let's get to prototyping then. So, in the prototyping section, we've all probably been there sometime. If people have never used any prototyping methods or anything, don't worry. This is a very, let's say, it's a very eager conversation. So, what you do for prototyping in the beginning is you set the stage. This is very important because you need to understand what your prototype means. Is it solving a problem statement within the company? Let's say if you're building it, your problem statement could be, does it work? Right? Does your technology work? If that's the problem statement the product is solving, you can focus on that. Does it sell? If that is the problem statement, focus the prototype and trying to sell it. If the problem statement is does it scale, then try to focus on that. Like for example, you may be able to make one, but can you make, let's say, 1 million products? If are you trying to scale? Are you trying to build? Are you trying to make it work? Are you trying to sell? It could be some, it could be all, it could be a few pieces also. Setting the stage for product development is important because if you are trying to, let's say you're trying to focus too much on can you make it, but in the end, once you make it, you've never thought about can you sell it, then again it's an exercise in vain. You got to go back to the loop and make one more prototype to prove that okay, hey, it sells. Then planning the POC and MVP. Right? Let's get to the stage later where I explain what is POC and what is MVP. POC is proof of concept and MVP, how they are different, MVP is minimum viable product, how they are different and what they mean for your case is something very important. You need to plan this. Then there is fail fast, fail cheap. I'll probably give you some of the cases that we've experienced in this segment earlier. Right. So in setting the stage, like I said, you should define your goal and what is your specific target. Are you solving the prototype solves what? Are you trying to see whether your team can build it, whether your team can sell it, someone else can sell it, you build it, someone else sells it, or someone else builds it, you sell it. Whatever your target is, define that and prototype that part. It's very important. Okay. Then identify dependencies. So here is a very important piece where sometimes you would probably, unless you're a very large corporate or you have a very large corporate, you would find yourself in a spot where you are not able to tackle all the nodes of product development and selling. You may be good at manufacturing, you may not be good at sales. You may have very huge number of channel partners which can sell any product, but you may have a very very early stage design pipeline or research pipeline. So what it does is you have to identify dependencies internally and identify dependencies externally. Let's say you're designing a product which involves electronics and mechanical. Do you have the engineering resources? If not, will you be able to outsource it? And if you're outsourcing, what are the costs involved? What is the lead time involved? Right? Those are identifying the dependencies. Allocating resources. So you have to figure out verticals. So if your product involves 2, 3, 4 verticals, if it involves design, if it involves UI UX, if it involves app development, if it involves any sort of let's say research or sales, you give ownership to individual verticals, right? You may be able to take up 1 or 2, but you have to distribute the ownership. You make somebody to ensure that hey, they develop the tech properly, somebody to ensure that hey, they understand the market and do customer support after sales properly. So you define the ownership. Here is where we get a quick understanding of what's the difference between proof of concept and minimum viable product. Proof of concept usually just needs to work. Okay? So if you're building let's say if you're building a bicycle, most important thing as a proof of concept, it needs to go from place A to B, right? That's the most important proof of concept. Use readily available material, tape up prototypes together, eliminate the risks, right? Like your biggest risk in bicycle is probably balancing or something. So you eliminate the risk and see, okay, your product or your design is solving the most important part of functionality, right? It's basic functionality. So this is proof of concept. If you're going towards minimum viable product, what it does is it usually has some sort of an interface. You either interface it with a buyer, with a manufacturer, with a seller, with somebody. Get that interaction out so it gives you a complete feedback as to what your product problem statement is and how far along you are in the way to solve it also. So that is one of the most important parts of an MVP. You need to expose it. That's when you will understand whether it's really viable or not. That is that's one point. Then you have to consider the aesthetics and ergonomics. How it's held, how it's touched, how it's felt, how people look at it, how people perceive colors, color theory, CMF, all of that comes into picture, which is part of the design. Then simulate the real world conditions, which means that you may be able to take a photo of it and take a poll of the client, but that may really not give you the valuable feedback. Take it to a mall, take it to an event, take it to places, take it to places where you're showing it in actual conditions, right? And let people use it and get a feedback. Then another part is engage earlier. You will probably never build a product that you will say, hey, I have tested it, I know it works, I'll sell it for it. No, you will have to expose it to a closed circle, which will probably give you very valuable feedback in the initial stages, which is probably shipping out with some sort of box and analysis. You get that feedback early on. When I say early stage adopters or early product adopters, they are usually the alpha beta testers, right? You may have this word very common. Alpha beta testers, they will give you a feedback as to this is working, this is not working, not required, too much effort in this, so on and so forth. So that will give you a feedback from community, and you may be able to get valuable solutions or pre-made solutions for your feedback which is given by earlier. That's the difference between proof of concept and MVP, right? Next is very fast, very simple. Yes, of course, you don't want to spend too much time and too much resource on figuring out something that's it's not working. And you spent, let's say, 5 years on building something, and you spent, let's say, millions of dollars on building something, and figure out that hey, nobody wants this now. That's something that you may not want. So try to build something with like previously I said, right? Use existing materials, use taped up prototypes. Quickly check if it's going to work or not. Then cross-functional collaboration. At a very early stage, it's important for you to understand different verticals that are getting involved in product. If you're developing a product, it's important to get alignment on all of the aspects of the product. If it is development, design, production, sales, everything. I to give an example of a POS system. You might have seen POS systems, right? That you go buy anything in a shop, you swipe the card. There's a touch screen. They enter all your details. Annoyingly ask you for OTP, and then you're like, I don't want to give OTP. So that's a POS system, right? So we're developing POS system for a company, it's a mass market company. At a very early stage, when we were before even starting sketching of that product, we got all of the stakeholders aligned. Do you need one display? Do you need two displays? So how many touchscreen do you need? Does both of the display have to be touchscreen? What is the size of the display? What are the colors you want? Which are the stores you're going? How are you going to sell it? At what price point you're going to sell it? What are the new features you're going to give? All of this alignment was done at the very beginning, which allowed the company to align resources and give information to their sales partners and channel partners that hey, this is the product in the pipeline. Try to find out if anybody is interested. Aligning all of those verticals is very important at the beginning of the project itself.
That is only required in the existing product, the one which you
this cross-function. It could be anything. Existing, new. If you're building anything new, it's even more important than existing because in an existing one you have some references at least, right? Very, very, very crucial when you're building something new for sure. So right now, as a part of the session, This is what I've covered in terms of understanding the market, how to set up ideation, and how to go about prototyping. What we can look at next is a case study, right? Classic case studies where I tell what we did. This is not what I want to do. What I want you guys to do is do a quick exercise on this. Okay, this is again interactive one. So what we will do in this case study is we will do an exercise. I want you guys to imagine that you are providing a solution to a fitness company that is efficient, safe, and specifically tailored to the Indian market. I'll go again. I want you guys to imagine that you're providing a solution to a fitness company that is affordable, efficient, safe, and tailored to the Indian market. So these are the important points that they want in the solution. Let's say I'm a fitness company. I'm coming to all of you guys and saying, "Hey, I want a solution. I want something. I cannot specify what that is. I want something that is safe, efficient, and affordable, plus very much specifically tailored to the Indian market." How do we go about this? It's simple. What I want to do is you can scan this QR code in your phones right now. You will get a page, right? On that page is a complete description of what the problem statement is and what the let's say what the company needs, right? Let me know if anybody is facing difficulty in scanning this and opening up. Okay. So if all of you got the chance to open this page, there is an introduction section where it defines what a particular, what the main point of this case study is. Then after that, there's a section where there's a company overview, and it tells exactly what this company is about. So we call this company as FireFit, and it's a fitness-focused company. What is the main company goal? Like I mentioned, right? Is it the Maruti? Is it Bentley? Will be defined in some sort of way in this company overview. Take your time and read it. You may want to go over it again and again. Then there's a background of what are the problem statements, this target audience, and data points. So basically, once you go with this, I would like you guys to complete and sort of build an idea as to what could solve the problems that are mentioned in this document. You can write that idea on a piece of paper and stick it over there. I will erase that board. Come up with an idea or a concept for the solution. That is one thing. Second thing is we have to figure out how to do a proof of concept. So I'm going to ask you simply, how will you ask that company to do a proof of concept and what that proof of concept is? Right. So I'll write a few things over here. So the first thing that we will be looking at is idea, right? We'll stick up all the ideas over here. We'll put up all the POCs over here, and then we'll put up all the MVPs over here. Okay? So we have to come up with three things, which is what is the idea, how do we prove the concept, and how do we go about the MVP. When we look at how do we go about the MVP, I want you guys to think, what is it that you will validate, how will you validate, and what are the steps to validate the MVP. Right? So you guys can take your time, you guys can think about it, you guys can ask questions, as to why this problem statement was written. You guys can treat some of us, or you guys can treat each other as potential customers. You guys can start thinking, hey, did you face this problem? Did you do this? Did you do that? What did you try? You guys can start conversing, you guys can start interacting. Some of us are here. You guys can try to understand, if this problem exists in a certain way, how do you go about tackling it? Has anybody worked in a fitness space before? Anything? You worked in the fitness space before? What What was your role in a fitness background?
Actually, I run a company where we develop the medical wearable products for listeners.
Oh, nice, interesting.
We help the client to launch in US market.
Oh,
It's running successfully, but for Indian market, we want to reverse engineering and doing it.
so you understand the affordability and tailoring to an Indian market as a, seems like a very, very similar case. In the previous segments, was anybody able to relate to some of the problem statements that I was telling? Let's say aligning different people in a company, or understanding, validating ideas, finding out at a later stage that a problem statement is away. Was anybody able to relate? Has anybody felt some of this before?
Yes. Yes.
Yeah. What did you feel, or what were you able to relate to?
Initially you go right, first you objective. I implemented one. Later point of time, I thought that okay, this is going high cost. User will not wait. Again, I am coming back to first step. So whatever challenges, problems I faced, here I am seeing in your slides.
So what did you do next as a next step when you identified that hey, your cost package is not really fitting?
So I come back and I'm trying to make the product in a cost-effective way by trying to plan in a bulk production rather than a small costing. Then I cut down the product in the half. Means instead of giving more number of days, I reduce to half. So that I cut down the half of the cost. The PCB size has been reduced. So like that.
Okay, so you prioritize certain features,
Yes.
and yeah, you looked at scalability, right? Because scalability had the key. How did you come to figure? How did you figure out that scalability had the key to your cost solution? Did you try one, and like how did you figure out that scalability was the key to solution cost, or engineering was the key to the cost?
Uh, so there are different techniques like molding way, and there is a 3D molding. There are different techniques. So if you wanted to go in the larger scale, the molding cost will be like very cheaper. For the smaller production, it is double the cost. So those are challenges.
So you spoke to vendors, you spoke to people who are in the industry, and then you got quotations. Okay, cross-examined. Has anybody else gone through a cost analysis or a scalability analysis to in their previous work, or trying to do something new? Have you been through a cost optimization journey before? Right. So did everybody go through the entire document, or have you guys started ideating already? Yeah, please. I'll put it. Please have a seat. Okay. It's all right. It's all right. Yes. What is it? What does the solution look like in your mind? What does the solution look like? What will the POC be? Which means, what will you prove? Will you prove that it can be made? Will you prove that it can be sold? Will you prove that it can be scaled? What will you prove also? And how will you prove it? Right, like exactly like how he said, right? He was able to prove that he was able to make the component, but he was not able to prove that he'll sell it, or he was not able to prove that he'll scale it. So he started talking to manufacturers and understanding different processes of scale. That's how he was. After that exercise, only you understood that hey, if I do injection molding, only then will it be feasible. Only then will I be able to sell it. Which means I need to design for injection molding, or I need to capitalize for injection molding. That's the learning out of his experience.
question I had. What should be the process of this? So, should I think of an idea first, then through that idea I should develop an MVP?
Yeah, idea, POC, MVP. That's the first. Idea, POC, MVP. Eventually, your MVP should validate all of the problem statements. Has anybody faced this problem in your journey? Like whatever is mentioned in that document, have you faced some of the problems? Has anybody been to a fitness space, gym, or a class, or where you have faced some of these problems? What is mentioned in that? Has any of your friends, family faced this issue? Have you come across this in real life?
Yes, I tried to.
Okay.
But then it's like which equipment to use and how often to use.
How much you are going to use?
Yeah, how much I have to use. So at the beginning, I had a coach.
Okay.
So he told me to just do whatever you like because that was the beginning stage.
Okay.
In the later stage, I come to my college, so there was no coach. So even if I use any app or any like other digital thing, I can't trust it. It looks like it's built for general, and maybe it's not built for me, or maybe it's built for someone who is like much healthier or maybe like different body weight or something.
Okay.
It's not very trustable.
You didn't feel like a solution was tailored for you when you were with it.
The trust issue.
Trust
I
issue.
can't really trust.
Trust.
And maybe at the backside there will be some human who you talk to me.
Understood.
But I think what is like more a problem with the fitness because one person is actually motivated to be fit. That person don't need anything except like a suit. Right?
Yes.
And even suits are not expensive. So the overall problem is to do something which motivates that person.
Correct. So you can include motivation as part of your solution, right? If you feel like that's one of the major problem statement. Motivation could be part of your solution. So if you're trying to solve for motivation, what is an idea that comes to your mind, right? Like,
incentivizing running for 4 kilometers or doing 3,000, 300 calories a day.
there's an app in US that pays you for walking. I think there was another recently somebody tried, right? I think Apple Watch Ultra, if you completed 10,000 steps every day for a period of so many days, you get the Ultra Watch free or something. There was one of those campaigns as well. So that's one of the ideas. Yeah. Have you written any of that? You can write it and I'll put it up. Anybody else have a thought about how to do POC? Have any of you done an MVP before for any other companies, or have you sold a product and got a feedback from any of the customers saying, hey, I need this bigger, I need this smaller, I need this to look something else? Have you got any of the feedback? What was your experience or your journey trying to incorporate that feedback back into the team? Have you felt anything or experienced anything before that you would like to further use? Because I identify that all of you here are trying to build a new product, or trying to establish a new segment, or trying to develop some hardware, right? So, as you do it, is there an experience from your previous time that you would like to share? Like, hey, this is what I'm going to use, and ensure that journey is smoothed out.
So, like, 1 year before, we were working on building an AI
AI like a ChatGPT only, but at that time ChatGPT do not have personalization feature. So
Okay.
you have to give it real personalization, we will connect email and reminder features like those things. So we built an app and we did our first launch to a few people, around 60 people. We give them, app to use. The problem is they did not use it.
Okay.
So it's like, so few people, just like one or two people, like those are very close to us, we call and like two of them we use. But most of the people did not use it. So getting feedback is like, I think we should done some reward thing in that section, like.
Yeah.
But it's like if we have to reward thing for feedback, it's very like, weird thing to do, because anyway they're not using. So maybe this is the feedback that they are not using it. So this is like my experience.
Nice, interesting. So in case you're building something now, if you're building something else, right? How would you tackle getting feedback, right? Or what would your first instinct be to tackle feedback? Considering that, okay, if you have really reward for feedback, then the product itself may not fit the space, right? So if that was your problem first, maybe you want to try and ensure that, hey, I will collect at least 100 people who are willingly coming to me and saying, hey, Meru, give me that thing so I can use it. Like, what's your go-to thing to first say, okay, I will understand whether somebody wants it or not.
So what I feel is maybe the people we choose are not really needed that much.
Okay.
So we have to first look for the people who really need those things. And to ensure that they need it, it means they're willing to pay for it.
Yes.
So it means that at the beginning we should not distribute our product for free. Like maybe we say, okay, like give some security, like it will have a 100% refund or something. But maybe it's like selling at the first time, like at the first day only. So another thing I thought is like it's like not clear to me how to do that. So, anyway.
If anybody else maybe can give an idea as to how you got feedback? Because one person there, yeah.
Actually, I would like to share. Actually, see, even though the product we designed launched in US market, so we thought like since it's launched in US market, let us immediately launch in Indian market.
Okay.
But geographically, like the acceptance of there and there is totally different. So when we started trying in Indian market, to some of the features at least, see actually one is like here we are having a little bit thick skin actually. It's a leg massager, and people said it's not massaging so effectively, and some people even said it's a cheap product actually. So then we understood like geographically, and also their viewers like they want it's the main target is for athletes actually.
Yeah.
So they want like compression. But here we want more compression. We should feel that it's you should tighten your leg in such a way. Even if worker who work from the farm house also or any farmer also should have that feel it's compressing my leg perfectly. So likewise, some of the feedback we got on the intensity, there are some two different massage we have given. But here people are asking, like at least 6 to 7 different massages if you do, like our mother massages, step likewise, some people they ask. Some people they ask, so it's different, like our physiotherapist will massage, likewise we want. Likewise, we have taken complete feedback. Then we started improving. Then we have hold our launch and we said let us rework on what do we do. So these are some of the experience we got.
Nice, nice. Thanks for sharing. Thanks for sharing your feedback or your experience. Actually, this is a very important one.
Right.
Awesome. So what we can do next is, if you guys have figured out any of the ideas or solutions, you can put it up. Otherwise, this is a case study in for yourself. You have access to this page. You have access to the entire document. Feel free to write about it. You all have any ways to contact. You want to brainstorm. You want to ideate. You want to build on it. Feel free to tell. That's about it as part of my session. So yeah, this is about us. From works, we will have a more detailed conversation as to what all of us are doing, how we can help each other, what's the sort of engagement we have. There's a complete networking session after this, and yeah, I think yeah, I'm about to mark done. So this is the end of my session. I let Srinivas take over. He has a bit, he also has a few things, and he's going to be contributing a lot about designing for manufacturing and scaling up a product as in itself. So Srinivas, over to you.
Thank you for the reference. So before we go into second week, we will take a quick 5 minute recess with a few refreshments on the social service. It's 5:26 right now. 5-10 minutes.
Validated, tested, make a few hundred pieces, tested to the Next morning, I see some back to home. Different person, depending on the region, their qualification, quality qualification, or low cost quality qualification, for very good education, holding application. To be in the class 8 team, not everyone will have class 8 team. So those are different. That cost is even costly. That those are different. Is the stage where you say, around my design was for 1 or 10. This is the same design for definitely. You need to change that. Easy as well. 1 unit you spread 1 day. 1 million units you can't spread 1 day. So spread 10 seconds, 30 seconds. You need to change the design. Design manufacturing. So the few service was everybody is running an after product. We really want to do one product. Then you put change, make some business into one product. Once you are satisfied, if there was I don't want to change anything, then you do it. Because every time you do everything, it's going to cost us. So once you do it, everything you go marketing, you look at don't know 1 million, 5,000, 10,000, 20,000. To buy production schemes. What you say?
So if you get a feedback on the size component, again, but you get a software feedback on hardware feedback, you can always immediately change that and even the cost of software is very
Live thing out the announcement.
Excuse me, everybody. Can we start in about 2 to 3 minutes? Excuse me, everybody. We'll be starting the second session now.
Hi everyone. Am I audible? Yeah. So I think first we need to give an applause for the previous presentation. Oh, it's just like a warning symbol because mine is not going to be so professional. It's going to be very casual, but I will try to be as interactive as possible. So let me quickly start. So the presentation is going to be about hardware design and also how you take a design into manufacturing phase. So first let's get started with me. So basically, I just want to give a very small background, like how I got interested, because it's going to be a complete hardcore engineering. So before that, let me ask any one of you, I mean, obviously, like how many of you are into electronics, like hardware engineers or electronics engineers? I just want to count. Okay, so that's pretty good. Okay. So because it's going to be based on that, the complete presentation. So I hope you have some knowledge of electronics and how things work. So, and this is how my interest started. So I hope most of you have this similar kind of experience. So for me, it started something like this, then taking things apart, and that's how I slowly got into electronics. And also, I think other things are there. Many dumb things I did. Maybe you guys did as well. So one of that was I took a LED and put it in a power supply, just switch it on with a toothpick. Yeah, exactly. And other dumb thing would be like, have you seen that cloned video games? Used to play Contra and Mario. It's not official. Yeah, I used to like cut those wires and try to connect it to a PC, and I can turn it on and like spoil my PC, something like that. So I think it would be interesting. Any of one of you want to share like any of those experience? Something very dumb? Would have done it like yeah, sure.
I plug the speaker into 30 volts.
Ah.
Trying to amplify.
So anybody else? I think the base would have been very good. No, nothing you can share. It's just YouTube, LinkedIn, and what else? I don't know. LinkedIn and Instagram. Yeah, some 3 or 4 platforms streaming, so we can pick it up. So yeah, let's get a little more deeper. So initially, that's how my interest was. I was just an enthusiast. I was just learning everything on my own. Then college started, usual like all theoretical, and things were going on normal. Then like accidentally, I got into a organization. It's called Be Automate India. So it's basically like a research and development. It's like a consultancy, and they were working on some medical devices. So that's how I got into like how to take the theoretical, put it into practical stuff. So that's me sitting and solving something. I have no idea what it is. Yeah. So that is Be Automate India. They were incubated in BMS College of Engineering. So that's near Baswantudi, within Bangalore. Then from there, I worked there almost for like 1.5 to 2 years. From there, I moved to a company called Analogy Design. So it's a industrial design studio. It's based on Indranagar. So basically, what they do is they take some crazy ideas which is not already executed. For example, like they were explaining the presentation about like invisible headphones. Yeah, so we take some crazy concept. So one of the concept I was working on was electric hookah. So basically, we're converting actual hookah into electric one. And apart from that, there were like a few more other products, which like eventually won't be in market. Maybe probably next 5 or 10 years it will come into the market, something like that. So once this is done, I was working here also almost for 2 years. Then from there, I moved to rapid prototyping and manufacturing. So it's, if you can see, it's like a flow. Like I started with just the R&D. There is no production or anything. Then from there, I went to a company where people start ideating ideas and actually converting the theory, practical concept into a product that you can actually sell it to someone. And also, this is where actually I understood about form factors, like the actual, I don't know if you have had this conversation with the designers, where they'll be very adamant on some things. The design has to be such a way, and they'll be engineers will be like completely against it. It is impossible to do like an engineering solution. So all that back and forth happened in and then finally for rapid prototyping and manufacturing, I was working in 44-volt design. So here basically it was like much higher end. So what I was doing, you see it's like steps. The third step was completely into design and manufacturing focus. So that's one of the projects what I was working on was a video doorbell. So it's basically like Amazon Ring. We are trying to recreate. It uses embedded Linux. The IC is based on NXP IMX93. So that is also one of the cutting edge IC. I think we started using it and we were the first one to start using the IC into the product. So that's it about me, and this is my company called PCB Cupid. So the goal of what I wanted to build was I want to build India's largest open source hardware ecosystem as well as a community. So let me go live first. And I think you guys know about Adafruit and Seed Studio, and there is something called a Spark Fund and more like a wave share and stuff. So I just want answer from your side. Why do you think we need a company similar to this in India?
Documentation.
More?
Like customs.
Customs? Oh, yeah, that's a good answer. You don't have to pay 13%.
No, so for going for a product from Adafruit, so there will be like a good documentation for the product. But like if you are taking a similar product from local market, like there will be like zero documentation. You need to figure out for yourself what exactly is going on.
Yeah,
So
exactly.
if you
That's
are racing figure, like you won't be having no idea. You may block this board maybe.
yeah.
So like this will be having good articles and documentations.
So that's excellent answer actually. That is one of the answer I was looking for. Because if you buy anything apart from these companies, there's a very high chance you won't get any support or any documentation. Apart from that, anything else you can think of? Just think of like in a much bigger picture. How would it help?
Lead time to get unique boards, modules, what we used to get.
Yeah, that's a really good answer. Another one, because Adafruit is the one like who are like industry leading in terms of open source. Any IC, any product that comes into the market, they'll be the first one to release a development board. So that's another thing. But there is one key point that I'm looking.
So one more thing is that, like I think like most of the house almost like all of the boards and modules from Adafruit are open source. So you will get entire schematic. If you want to replicate it, then you can do that.
Okay, that's something point I forgot he told, but still there's one more point.
It's in the name, development mode. So if you have a development mode, developing the thing makes it's faster.
Yeah.
It's very fast.
Exactly, that is very close to the answer. So what I was expecting was, in terms like if you see in a large scale, let's say these ICs, whatever they're using, right? None of them is manufactured here in India, correct? So the same thing like most of the ICs in these products, if you see, it will be from their own country. For example, take C Studio. The most of the ICs will be based on ESP32, and they do use other brand. I'm not telling their own, but whatever they try to push will be their own product. Same thing goes for the Adafruit also. They are very patriotic towards USA. So they are very proud to produce something that's made in USA and sell in USA. And even now they don't outsource it anywhere else, and they completely manufacture in-house in USA. So when I was going through all this concept and I was showing you my past experience, right? So the one of the two answers was the documentation and the schematics. So we would always prefer to go with this because it's very fast development, easy to get the schematic and get the documentation and everything and get an effect. But one of the biggest problem with these companies are they see what is easiest for them to implement and push it to the market, and what are the partnership they have and push it to market. Let's say an Indian company which is like producing IC, and you can't expect them to use that particular IC and make a development code out of it. So there are multiple reasons. One is obviously the product that we are going to produce in the first initial lot will be inferior to any of the products that's already there in the market. So that is going to be a very big drawback because we don't have the community. If anybody even launches any product in the market like a silicon, so nobody is going to make a development code for it. They won't make the development code for it. So that's why what I wanted to do was build a community with the existing hardware. I'm not expecting to have like a Indian silicon and then make the hardware. So even before it release, I want to make a ecosystem which already has all the modules integrated, which already have a microcontroller. It can be anything. So all this integration before, so that each time there is a new IC or something is launched, so I can remove one part of it and keep replacing it with the Made in India products. So that is the overall goal why we started this PCB equipment. And also, we made sure each one of the points you guys told, having the documentation, having the schematic, having the Gerber, or like making it very easy to access, all those are our guidelines, which we like very strictly follow. Make sure all those are released while the boards are released. So this was our first 3 products. That was called as Glyph C3, H2, and C6. And all 3 are based on ESP32 basically. So there is a key reason why we chose particularly C3, H2 and C6 was because it's a risk-based architecture. So I thought maybe like in future, if people started adopting risk more, there might be more support for this. And also the cost will be obviously lower because there is no ARM licensing fee for this. So that is one of the reasons why we are using this. And apart from that, it has like a bunch of features, like it has a quick connector, and we have a LinkPort charging circuit, and also we have a battery monitoring circuit, and you can see it's a USB enabled, and also it has a dedicated switch to turn on and turn off the battery. So currently these are the companies that we are working with, and some of these companies are using our board. Namely few like 44 volts is using for design purpose, and Educantra and Notronics, they are like our teaching partner. They use our products to teach programming and hardware for schools and colleges, and obviously Titan and other companies are there. So I just wanted to take this as an example and show you how we are making a very very cost competitive product that's going to the market, because cost plays a very huge factor, and it doesn't matter whatever points we had in the beginning, right? Everything goes out of the window as soon as the cost comes into play, because the cost of Adafruit. Okay, let's go to the next slide. Yeah, this is the same thing that we were discussing. What are the features and what is the main goal? So that is the same goal that we are following to make the Glyph. Yeah. So here comes the competition. So the cost we can see here. So same thing with Adafruit. It's an ESP32 C6. If we are comparing that, but our C3 series is much cheaper. It starts from 434 or something, and that is inclusive of tax and our profit margin and everything. So if you see the same boards, the same specifications and everything, starts with 1800. That's from Adafruit, and that is from Think Plus. That's from Sparkfun. Again, that is like 2000 rupees. And this is from Seed Studio. They are the cheapest one before when we came into the market. That is 533. And the 634 is from 770. They are also Indian manufacturer, but it lacks all the feature what the first two products or the first three products have. It is just a microcontroller and just has a USB, no extra feature. Nothing. So our goal was to keep Seed Studio as a target. So we want to hit that target. And this is how we broke down the features. So first thing what we did was, as the previous presentation we had, that was the feasibility of the features. So I put all the features that I can cramp into the same size. And also I think one more thing if you notice, you go back. Yeah, the form factor you can see, right? So this is adapted from Adafruit. So this is Adafruit form factor. I mean, the circuits are obviously different, but the pinouts, the layout, the placement, everything is very, very similar to Adafruit. There's another reason why we did that, because Adafruit is one of the industry leader, as I told. They already have a very huge line of something called as wings, which they can put it on top of their products. So that is the reason why we made it compatible with this. So in case some people are using Adafruit product in India, they can also replace it with a cheaper product. So that is another idea. Yeah. So in the feature breakdown, I put all the options that I wanted. So you can see we have the same Adafruit footprint. Then we have USB programming. Then UART. That swapping different microcontroller was the one I was talking about. Like remove the board and you can put another board. That's how we have C3, C6, and S2. Everything is pin-to-pin compatible. So you can remove one and put the other one. And other ICs we are planning are ESP32 S3, Raspberry Pi Pico. We are planning to do Atmega STM, and also like we are working on some of the support boards. Apart from that, it has a LiPo battery, charger on board, and we added some extra feature. But you can see that lithium phosphide we removed, and external antenna we removed. There is no SD card, there is no Ethernet, buck boost converter. So again, all this collection, how we selected was very similar to the previous presentation. How we go through the feasibility study and see cost and also the time to implement the features. So yeah, so then once the features are selected, what we want, we did the part selection. Based on these features, we need the parts to build it. So these are the three major parts that we went through: C3, C6, H2. To be honest, initially we never had an idea that making a swappable ones. So initially we were looking into only C3 because C Studio had only C3 in the market and the cost was like 435 something. That's why our price is 434. So it's like 1 rupee less than that. So while researching more about it, we figured out it has a very similar pinout. So if you see the green markings around the ICs, right? So all three have very same pinout. I mean, you have to make some firmware changes, but hardware-wise it will look, and it's a drop-in replacement basically. The only difference is the C3 will have Wi-Fi, Bluetooth, C6 will have Wi-Fi, Bluetooth, and Zigbee, and H2 will have only Zigbee and Bluetooth. It does not have Wi-Fi. So these are the three different features. So we thought it would be much easier to do design one product and launch three products. So that is how we designed it. Yeah. So the other requirement, so you can see the how we went through the part selection. So it's basically you put all the features and then based on the features, select your parts. So you can see we go through a lot of websites. We plan through like go through DigiKey, Mouser, or whatever the platforms are there. We scrub through everything and look into what is the most effective component that we can use, both affordable at the same time it is ease of use also. And another major factor that plays is the documentation. So here, when you go to a website like LCSC, right, most of the components will be cheaper. But the thing is, as soon as you download, the documentation will be in Chinese. So even though you purchase, there is no point if you are not going to use that and how to use that. So that we have to be very careful when you are selecting a component. So that is one of the reasons why the products are much cheaper, because it's very hard for other people to immerse into their world and learn and build things. So if we can do that, I think obviously we can also make same price point as what they are making. So meeting their price point would be much difficult if you can understand the language, travel, and do other stuff. So basically, and one more thing we had an extra was the STEMMA QT and quick connector. So this is a connector which makes much easier to connect between our board to other existing boards on the market, like Adafruit, SparkFun, and recently when Arduino joined the wagon, so even they have the option to connect a quick connector. So basically, you can take our connector and put it in any of the ICs out of the box and work. So that was the concept. Sure.
Can you expand on how did you use DCK and Mozart to make your performance?
So initially, how we go through is first see the modules what is there in the market, because they are the one easy to get in, because DigiKey mouse takes a lot of time for something to come inside India. So what I would do is usually select the parts which is already there, take any platform that's easy to acquire the modules, try to experiment with the module, let's see what is the next version of the module or anything that's alternative to the module. Take these details, put in DigiKey or Mouser, then you go through a filtration system based on features and based on pricing, however the option you like, then that is how we come to the final conclusion. So yeah, I was talking about the quick connector. So it'll just make our life a lot easier because the sensors and modules are already there. So we don't have to make all those from the scratch. Instead, we can focus on making the upcoming sensors and upcoming modules so that the obsolete you guys can still use, but still the old, the newer ones will be much better to use from our side. Yeah, this is just a QR for the video which I made. It will just explain you through the how to do the part selection basically. If you want, you can just take a quick snapshot. So that video will explain what sir asked, right? Like how do I select the component in DigiKey and Mouser? So it will go much in detail about including the power specification, electrical specification of each component, and how to filter through that in DigiKey and Mouser. Yeah.
Parametric search, right? When you're saying DigiKey mouse filtration,
Yeah.
you mean parametric search, right?
Yeah, parametric search. So basically, in that video, I'll explain you like what parameters to look for, how do you go through the pricing, and how to select the component. So next is design optimization. Now, let's say we are done with the features, we source all the components, you made sure these components are compatible with the features that you need, and they'll work all together. So this has to be done beforehand before you jump into the design optimization. Once you figure out all this, make a prototype, make sure it works, then that is the next process, is the design optimization. So here what we do is, these are the common points that is very related to Glyph, and also you can follow the same thing in any of your designs. So one of the major points in ours is our drop-in replacement. So the components, as I told, the IC itself is a drop-in replacement. So anything we have like excess boards, we can actually just replace the IC and it will still work. The only issues we might face is the pinouts. The numbering will be different, but the IC functionality will be same. So it's just in the firmware thing that we have to change. But still, we produce 3 different PCB just to match the IC configuration. But if you are doing as a product, you don't have to worry about the silk screen. Since it's a development board, that's why we have those. But if you are doing it as a product, you don't have to worry about the drop-in replacement. You can actually keep replacing the product, like 3 different ICs. Second is use most commonly available parts. So that's a very important point. Make sure what are the components you're using, it's already there in India. So that is what I would suggest. You can still get it from abroad or other places, but the problem with that is again the lead time. So you have to wait at least 7 to 10 days for any component to arrive in India, then custom clearance, then you have to receive it, then you have to use the product. The easiest part would be look into any local market or local websites where you can easily get your hands on. Try to use those kind of products, or at least make sure there is a replacement for the products that you're getting from other places. So that is what one of the example you can say is we are using a voltage regulator here. It's from diodes. So those diode is a little expensive, and there is a Chinese alternative for that. So obviously, like if you want to make it a cheaper version, we can use the Chinese alternative, and the product cost will be lower. But the thing is, again, as I told about the documentation, power specification, you don't know anything about it. But it's a very good thing. Like if you're making a product, you can use that alternative, and you can use the diodes as your backup, basically. And then comes the placement of the components. This is not something very specific. It might not be very specific to your design, but it's very specific to our design, what we have done here. So as I told in the beginning, it's like one design, 3 different products. So here what we do is 80% of this, or 100%, none of the components will move. Even though there is a different routing for each of the boards to match specific numbers, 80%, like 100% of the time, the components will remain in the same position. So the advantage of this is we have to make only one single stencil. So we don't have to make more stencil, and also it reduces our cost in terms of R&D also. The other advantage is the components. When you procure, right, you do it X into 3. So that will be 3 times the components you're getting. So the overall cost of getting the raw material will be cheaper while making 3 different products. Then try to use same passive throughout the circuit. So this is something, again, it might be very specific, and also if your product is very cost effective or like you are competing for cost, that is something you can try. There you need to like compromise some of the feature to get the cost effectiveness. I'll just quickly show you here. So I think this schematic, again, it's an open source thing. The schematic is free, you can download and everything. And here the most thing you can observe is there is something called as a 5.1K resistor. So that resistor will be used throughout the circuit everywhere, but it is not the best option that we have. So that was supposed to be used only for the USB. So that is the USB-C standard where we have to use a 5.1K resistor and pull it down. And the same resistor I would have used in multiple places. For example, I would have used for the LEDs also. I would have used for switch, but it's not recommended. But the thing is, when if it's not recommended, it works. So again, that is something the compromise that you have to do based on your product and whether you have to do or not to do based on the design as well.
Will you compromise the functionality?
Yeah, again, how much of a functionality you need, it depends on that.
So LED requires 50 ohm resistor.
Yeah.
Suppose you requested 5.1.
Yeah. So the brightness of the LED will reduce. Yeah. So that is a compromise that you are making. The same thing will go for anything, like if you have a ADC or something, you can put like a 10K, which is what you want. But if you want to compromise in the price, you have to put a 5.1. Then again, it will be cheaper. So that is what happened for us also. Like we have the resistors, right? 5.1K resistors. So when we were making for 3,000 units, we had to procure 21,000. So the cost was like extremely low because you're getting 21,000 of those. But if you're getting again 10K, I have to make a separate lot. The cost will be again, for 3,000 unit, the cost will be higher. So between 3,000 and 21,000, will make a huge difference. Then we have tried to use the hardware features to the fullest. So whenever there is a feature in the hardware, even though you don't know whether it works or not, you make sure you implement the feature. So very good example is I tried Aether. So Aether, when they launched, I got the vehicle and it was going from 0 to 100 kilometers. So 100 is the maximum kilometer I can cover in a complete full charge. Now recently they launched the update, I think few months back, and now my vehicle can go like 110 kilometers. So that's the thing. Most of the things, if you can do something in the firmware, you just don't wait. Just completely like give us the feature. Maybe in the future you can just upgrade, so the customers also will be happy, and also you can add more value to your product. So the same thing we have done here, and also we have used that same thing to reduce the cost of the product as well here. So there is usually a serial to USB converter here. So again, that's very expensive. That's like if you're going for a branded one like Silicon. I think it's around, yeah. And again, CS340, I think it's again 30-40 rupees you'll get it. So again, the cost will increase. Again, it's a very price sensitive. So our product is only 433, and if I add the 30 rupees extra, it is going to be like around 470, which is again the competition was like 533 or 435 something. So this is how we optimize the design. And then other way is to panelize. So sometimes like you might put it in any platform and try to like check the price. So it would be always a good option to do the panelization and check. And obviously Line Circuit has their own inbuilt panelizer. It's called LC panel. So you can just drop in your Gerber and increase how many rows and how many panels you want, and you can do this. So like since it's getting panelized, cost of your single PCB will be cheaper than the getting the single individual PCB. And again, this is a video explaining other features. I am not talking about the panelization in very depth. There are features like V-grooves, mouse binds, and how we can combine different PCBs. All those things are there in the video. So next is automate everything. So it's very important. Like you don't get involved in the process once you release your design. So because it's going to take a lot of time, especially if you are like a solo founder or you have a very small team, you don't want to keep going back and forth between manufacturing and trying to figure out what is happening. So all it has to be done is once you do the design, you give it to the manufacturing, and all you want in the end is the final result or the final output. You shouldn't be involved in like getting the components. You shouldn't be like shipping something from your place to back to their place, and a lot of back and forth will be there. So in that case, you are going to waste a lot of your valuable times. So it's highly recommended. You need to try to automate everything. What I am trying to show here is the jig. So basically, we wanted to test our PCBs. Initially, we used to just upload the code, then put a LED around it, and see if the LED runs through it. But again, it's very inefficient way of doing it. So we made something like a Arduino Uno sheet that will sit on our board. So you can see that there's one of our board. On top of that, we have the jig, and this jig will adapt to any three of our boards. So all you have to do is just press. So it will take like hardly 2 or 3 seconds. It will go through all the pins. It will run all the communication protocol, check if everything is working. Then the PC will just show pass or fail. So the testing process is like reduced from say 3-4 minutes to like 3-4 seconds. So that's a very huge cut down. And when this cut down is done, like during the final production, right, the cost of your testing also will be a lot cheaper. So that is how our price is cheaper. So we are optimizing every single step. That is how we are trying to compete against the other price. Yeah, this is finding the manufacturer. This is very, very important. So you need to find someone who is very aligned to you and also who will help you throughout every single process. As I told you in the previous slide, it has to be completely automated. You don't have to get involved. So I would recommend even not have much human interaction because again that is going to take a lot of your time. So it's much better. Everything is automated and online. It's much faster, much quicker. So this is what I prefer. And obviously the one I chose was line circuit, and that is why we are sitting here. And I use every single process what they do. So we do fabrication with them, procurement, we do the assembly, and also the testing. So this is a complete process. I just wanted to quickly show you one of the projects that I was working on and how I'm managing the line circuit platform. So it's already uploaded. You just drop your Gerber here. I'll just give you the Gerber view. This is one of the other products that we are working. It's a relay module. We just want to make it same size as the lift board, so it just sits on top and it's much easier to use. And also it's a two-channel and much higher current capabilities than what's regularly available in the market. Then the other feature I use the most is the assembly. So here, like I told you, you don't want to get involved in the process. You make sure you put exact part number, exact reference number, and exact value here. And you can see all the components, what is used in a particular single project. Yeah. So these are the number of components that is used, and you can see the color marking. So those are DNP, so I don't want it to be soldered. And you can see how many components they have received. And if I click on procurement, so yeah, so this was procured by line circuit, and some of the components I had remaining from the previous project, so I shipped it to them and they have done the complete assembly for them. And we have, I think most of you use this before, right? So it's like if you have faced any issues in the PCB or Gerber, so this is where you get the feedback. And also the other feature is team member. This is also like a very good feature where if you are the founder or you are head of some design team, you don't want to get involved in the process of ordering and fixing mistakes. So this will be very helpful where you can add as a team, you can just add another team member who will be actually working on the hardware and fixes. So any TFM issues, they'll fix it, they'll approve, everything will be done. All you have to do is just do the payment and the process will be completed. And apart from this, yeah, this is a bomb procurement tool. Basically, you saw the other screen where I showed you all the bombs were listed, right? So this is another way of doing where you just have you just want to procure the bomb but not assemble or do the PCB. You just put your Excel sheet here, the upload bomb, and it automatically scrub through your bomb and you see whatever is there in the warehouse. It select those components and it will give you the pricing for it instead. So yeah, that's it from my side. So you guys have any questions? You can have a very small session about it. Yeah.
I've seen smartphone is mostly illegal. Smartphone
Huh.
mostly uses illegal as a platform.
Yeah.
Platform also plays a very big role in the cost, right? Because once you go for bigger PC,
Yeah.
legal is not a
Yeah.
so we want to consume.
Yeah. So again, we try to use most of our products or in-house designing tools completely as open source as possible. The reason is if you want to replicate it by yourself, it should be very easy. It's not be like there's some paywall behind it. For example, Eagle is one of them. If we buy a Eagle license and we make a bigger design, and if there is a paywall, you have to pay and then download Eagle and then use our project file. So especially in our case, we use everything based on KiCad. So this is completely open source. And other reason why you can trust KiCad is because it's been managed by a corporation called CERN. So have you heard of Large Hadron Collider? So they are the one who is maintaining KiCad as well. So there's a high chances it's not going down anytime soon. And also they keep releasing the release cycle for them is every single year they'll be releasing the features, and it's not up to the mark as an industry standard like say go with Altium or OrCAD, but it'll get most of the jobs done. So if your PCB is 2-layer or 4-layer, I think that should be more than enough. KiCad. So any other questions? Okay, that's it. We'll end it. Thank you so much. Yeah. Yeah. So again, it depends. Like if the component is very complex, let's say it's a BGA or something. So BGA components will have the pads on the back, so it's very hard to assemble in hand. But we can try. It will be cheaper as well. Like if you do manually. But the thing is, it's not recommended. Like you're not sure whether it's going to work or not. So in that case, you have to make a stencil, then do assembly. It's going to be very expensive. But if your component is like something that can be hand soldered, that is a very good option for manual assembly. So it will be a lot cheaper for 1 or 2 pieces.
My question is, I have to give one or two prototype boards also to assemble.
Yeah, you can. So you mean you're asking the line assembly platform, right? Yeah, there is an option where you can select between automated and manual assembly. So you can select whichever you want. Okay. There is no minimum quantity order.
So when we opt for manual assembly, they also safety component together with the PCB. We can assemble at our workspace.
Yeah, you can do that. So you can procure it separate, and then you get the PCB separate, and then just get it to your place, and you can assemble it.
Immediately start the process of procuring or
no, I think it's in the order process itself. So you don't have to select the assembly option. You can skip the assembly option. So then just do the
and then we will procure.
yeah, just the BOM and the PCB.
What's the lead time for the components from?
Again, if it is in the warehouse, I think you'll get it in 1 day. If it is in a different warehouse, I think it might take 3-4 days to ship.
And globally,
Sorry.
globally from America or Europe.
So you want to get it from there?
14 or a DG.
No, I don't get your question. You want to ship it from here to there or
No, from there to here. Through let's say through one service.
It will take the standard lead time, whatever the lead time they have, right? It's the same.
It's like 2 weeks and 2 weeks or something.
No. It will be shorter. If you are doing through LC, it will be. Yeah, I think the better option would be Rohit. So Rohit will take over for the questions.
Is it 10 or 10? Someone says 7. Please don't give me notes.
So right now, I just do something because it came up. So we are, we are building a component warehouse in India. So the idea is, what is the use of building all the boards faster if you don't have components, right? So right now in Make in India, you can do something like 5 days, right? Like plus or minus a couple of days. But we want to bring it down to 2 days, right? So ideally, if you put a 2-layer board, you should be able to do it in 48 hours, right? That's what we are aiming towards. And we are very positive that we'll be able to achieve that in this year. So So there are a lot of nuances, right? Like in manufacturing, just like how the other speakers spoke about product design and Srinivas about like the entire manufacturing. Manufacturing itself is very complicated. Like especially PCB manufacturing has about easily a two-layer board will have 20 to 25 different processes. So we have fairly automated most of it, so that we have a tighter control, we have tighter quality control, we have tighter time-wise also. But let's say you are doing this, and on an 18th or 19th process, something goes bad. You have to discard that, restart again from the first, right? So as a country, we have not developed as much as what China is, right? When we make trips to China, we frequently make trips to China to understand how it is done there, right? It's like, to give a comparison, a very small example, right? There are about 2,000 factories. 2,000 factories. Not in China, just in Shenzhen area. Just in Shenzhen area, 50-kilometer radius, 2,000 factories. How much are there in entire India? Probably around 200 to 50 factories, plus or minus 25, right? So we need to like realize that, hey, we need to get there, but we are here. So that is the first thing. So we understand we are not there, but we want to go there, right? We want to build India's or the world's largest factory, right? That is our aim, and we are working towards that. In this journey, what we have done so far is basically make in India service for 2-layer, right? Like we want to do that for at least up to 10, 12 layers, right? So that everyone can get the benefit. See, with 2-layer, you will be able to like fairly do complex things. Like 2-layer is the bulk of the market. But I think what happens is, if you want to build like, let's say, Srinivas was telling about one product, like a camera-based product, right? If you want to build a camera, you really need at least minimum 4-layer or probably 6-layer. Sometimes if you really want it to be very small and small form factor, it could be 8 or 10 layers. So we want to basically build, we want to enable everyone to make sure that even that is more affordable in India, right? So that is what we are working towards. So similarly, we understand that components is also, there is no DigiKey and Mouser in India, right? And they get the biggest share from India. And they don't want to invest in India to make a warehouse in India. None of them are Indian companies. We need to be realistic here, right? Like we love open market, but we need Indian companies to establish warehouses in India to serve Indian market, India first, right? So with that mindset, we have already made significant progress on components. So in fact, actually today you can go to Land Circuits and do a search on components, right? Like you can search components on our static page. Like if you go to landcircuits.com/parts, we have about 3 million plus parts in our inventory. We have built a kind of virtual warehouse operating from Hong Kong, right? But we are going to start building a physical warehouse, right? Pretty much a lot of them have already been built in the ground and first floor in this same facility. So we are going to be starting to ship a lot of components from this facility. So when you see this, so basically you will get all the data sheet, part number. Soon you will start seeing that, okay, this part number might not be there in our Bangalore facility. So we would recommend you, okay, so with the same spec, why not, instead of buying this NPN, you have a different manufacturing part number, but it's available to ship right away, right? So our goal is, if you want to, if you order a component today, before 3 p.m., it should be shipped today so that you get it tomorrow, right? So now you can start thinking like how you can start creating iterations and product iterations faster and faster so that you can all build products faster and take it to market faster, right? So we're getting there, but I think today we take about 7 to 10 days, right? A lot of times we have done it in 5 days also. But right now, because it has to go through the customs process, it is taking time. But we are already working on a green channel, right? Because we do a lot of shipments on a daily basis. We are working with the customs department very closely to set up our own channel. It's called a AEO operator. So we are qualifying for an AEO operator grade 2, which means that we can ship all these parts without any custom clearance process on a daily basis. So it's more of a trust channel, right? Like they know that okay, Vita Pro is a trusted channel, so they're going to ship and then do a self-declaration. So with that, we want to support everyone with a faster shipment, right, or more reliable basis. But however, our long-term game is we are going to start everything in India, right? So we are building one of the largest warehouses for electronic components in India. So and so with that, like feel free to ask any other questions related to client service.
You have been in the market for 4-5 years now.
Yeah, slightly more than that. Yeah.
Slightly more. In this period, I have been your user maybe 4 or 5 years. Small quantity, but I have been your user. I have seen you go on. If I remember the first website and now what it is, I can see the field. And you have frankly admitted you are not like the PCB way in China or something. There may be problems. In one of the PC meetings recently, I was present there. One investor says, India is not a good place for manufacturing because there are some endemic problems in our system. So that's why that investor did not want to invest in anything based on manufacturing. Now you have been this one of the very tricky processes. This PCB making has a good number of processes. What is your experience in this field in the last 5 years?
Got it. Yeah.
Basically, if possible, I want you to answer the question of that investor. Whether manufacturing can be attempted and a success can be worked out. Yeah.
Definitely. See, I think a short answer is yes, right? A long form answer is it's not easy, right? There are a lot of nuances. So sometimes I feel like, I give this example always, right? The best way that a government can support any manufacturing company is to just stay out of a manufacturing company. Don't interfere with this. Just let us be what we are, right? Do our things. Don't come on a daily basis, right? That's I've told this to a lot of executives, to a lot of principal secretaries and stuff. But see, finally at the end of the day, it's us who have to drive it, right? Definitely, there are a lot of problems. It's not an easy country to do manufacturing yet, and especially few states are more favorable, right? But we need to figure out, right? As an entrepreneur, you don't have any option. You have to figure out how to work around all these things. And coming to the investor standpoint, yes, because a lot of traditional VCs, right? Always they have this concern about setting up manufacturing, especially if manufacturing involves a lot of processes and capital-intensive machineries, right? So, for example, I was looking at one of a factory of bicycle manufacturing, e-bicycle manufacturing. So it's a huge plant, but the number of machines is very low, right? Basically, the plant size is very big. You have assembly line, right? The amount of manufacturing that you are doing there is mostly assembly and a few paint shops, and things like that, right? Whereas if you come to something like a PCB, it's a whole new level. Every single process has a machine. Every single process has electrochemical, not just electromechanical, and chemistry to it. So it's more complex, which means whenever you have chemical involved, few more agencies of government gets attached. So when you have, depending on what type of chemical you are using, few more agencies get attached. So the more and more agencies, government agencies get attached, the more complex it becomes, right? So running a bicycle assembly or a plant which manufacture is relatively easier compared to a fab plant, right? Now I give this example. So everyone is talking about semiconductor manufacturing and crores of rupees getting invested in fab plants, right? So my background is in semiconductor. I used to work in a semiconductor company before starting Reliance Circuits, right? So this fab is probably like 100 times or even 1,000 times more complicated than a PCB. So if somebody can set up a fab plant in India, definitely PCB plants are possible, right? But huge amount of discipline, running, in terms of operational execution is needed. The environment is not very conducive, but it's okay, like we have to figure it out, right? So probably that's why if you see like there are all the semiconductor companies are coming in a specific region in the country, right? Like mostly Gujarat, right? That's also because when we travel there, it is more conducive there, right? There are specific categories of zones of factories being created there, and not just, when they say factory zones and stuff, it's not just land and road. Typically what is happening here, unfortunately, is we are also in one of the industrial estates in outskirts of Bangalore called Dabaspeed, right? One of our plant is there. It is not up to mark. It's not up to where it is supposed to be, right? Basically, by having a land and road, wouldn't become an industrial layout, right? So it needs a lot of infrastructure. There is no water. There is no proper power, right? In Pune, at least, where we are sitting, like the power fluctuation is it's around like 220, 225, within that range, right? So that comes about 430, 435. It's pretty stable here. But I get calls at midnight, say from our Davos-based facility, saying something is not working, some power fluctuation happened and some machine went bad. Right? It's just so painful, right? Why do I have to deal with all these things, right? If we are able to just get that power properly, like a clean power, we are not even asking for plus or minus 5%. We are asking for like maybe 10, 15, 20%. It goes from 440 to 480. Now, how will the machine survive? Like they're all designed for 430, 440 volt, and it goes to 480, right? So now, the downside of that is that for every single machine where it is critical, we have to invest another 1.5 lakh just for a voltage regulator, so that we don't get these midnight calls, right? So, is this a pain? Yes, it's a pain. How do we handle this? Can government take care of this? Absolutely, government can absolutely take care of this. Are they willing to? I really don't know. Like I've given up on it. So the way I am working, or the way as a team we are all working, is whenever we come up with a new plant, we have to take at least 15 to 20% extra budget just to make sure that these kind of things that government should have taken care are taken care by us privately, independent of the government, right? So it costs us more than what a Chinese supplier sitting there would do. But it's just like mental peace versus daily, having to deal with it daily, right? So we learned a lot of these things in a hard way, right? So that's why a lot of people. So you see, like there are at least, you keep reading in news every day about the one or the other EMS company going public and stuff, right? So in the last 20 years, there is no single company in GCB which has gone public in India, right? It's hard. It's not about money. It's about know-hows, It's not about like if somebody gives like, so I keep giving this example, right? Like, so if let's say today we are fortunate to have, let's say, 10,000 crores, can we build an aircraft in the next 1 year? It's not possible, right? It's not possible. We don't know stuff, right? So a lot of times, so capital is important, and especially patient capital is more important, right? Investors being patient with us to see through the entire thing. I understand these nuances, but a bigger thing than capital is know-how. Like really understanding or having the knowledge of how to do that supersedes everything. Like for example, we'll be announcing one of our latest material research that we have done. So we have been focusing on a lot of these material research R&D because if you see, right, like if you compare China, we always compare China, right? Like anybody who wants to make a PCB will say, hey, JLC PCB you get like in $2. Why are you charging $10? Like to get it to $10, we have to really work through our way, right? So there are a lot of gaps. One of the biggest gap in India is material research, right? So like basically I always keep telling like chemical engineers, if anybody is in chemical engineering, please do chemical engineering. Please don't get into any other business analytics or management because I know a lot of my friends from other IITs, like they all want to do management, right? Like either get into consulting or software, and they don't want to stick to the code. So that is where a huge gap is, right? So today in India, especially coming from a PCB standpoint, right? We need a lot of material expertise. We import a lot of chemicals. A lot of PTH, like plated through hole, ENIG, and a lot of processes in our current plant. We painfully import these materials from America, Germany, right? And every time I import, every time we sign off a purchase order, we're like, why are we doing this, right? Can't we do something in India, right? So if somebody is there who is interested to work on these things, we always want to support them. We have invested in few companies who want to do material research. So right now, one of the things that is coming out of our material research efforts is something called direct immersion gold, right? So having the ability to deposit gold on top of copper without a nickel barrier, right, is very hard, right? And being able to develop it to 3 micron, 4 micron gold on top of copper opens a lot of applications, including defense, right? A lot of radar applications, high-speed RF applications need direct gold without nickel. So that was not possible to do in India. Right now, we are very proud. We are going to be launching it online also. So we have achieved about 4 micron gold deposition directly on copper, right? And we are going to be launching that process soon from our factory. So these are the things that we are working on, right? And if any one of you or any of your friends, they are interested in material research or anything related to PCB, processors, capital goods, we have to build it together, right? We want to support everyone. Like we want a capital goods ecosystem to be built in India. Because there are 2,000 factories in Shenzhen, they have every single machine manufacturer within a 50 kilometer radius. Here, we have to go to China if you have to even look at the machine, right? Like a new machine, advanced machine, right? China is not what it was 20 years back, right? So they've transformed significantly. They're probably much more advanced than United States, right? Like, having lived there for a lot of time in the US and comparing with China, it's a huge difference. China is way advanced in infrastructure and everything else. I was basically in San Francisco. San Francisco has become a dump, right? Like, you see all homeless people there in San Francisco. But if you go to China in Shenzhen, it's just, you will feel like, it's another world, right? They are able to do that in the last 10 years. Not like 50 years or something. Last 10 years, 10 years before China, 10 years after, like now, it's huge change. So if they have done it, we can also do, right? Like with the right mind and right, ecosystem. So I think it's more of a together, doing this together, right? So I thank you for being our customer, like for more than 5 years. Like I know, a lot of times we might have failed delivering on time or quality. Thanks for being patient and helping us out, staying put in this process. I think like that really fuels us a lot. That every single customer has really fueled us to become better, and we will continue to do that.
Thank you.
Yeah, thank you.
Thank you, Shiva. Thank you, Murli. That was a very insightful session. So we've officially closed the workshop that we had planned. We will move into the networking session soon, but before that, we would love to get any feedback on the session. What did you guys think about the session, the content, anybody? Just quick thoughts. Oh, that's it. So there is a feedback form with the QR code over here. Please fill that out. It'll just take 2 seconds. And also, before we move into the networking session, we have about 10-15 minutes. If anybody wants to come up here and talk about their product, we have Purvendra, Srinivas, Lee, and the rest of the team here to help you out if anything is needed. Open platform, anybody? Okay, so we'll move into the networking session. The first session for the workshop series is closed. We will have 3 more sessions in the same FounderMode series upcoming in the next few weeks. We will dig deep into revenue strategies, pricing models, validating your product, supply chain and logistics and things like that. So do follow us on LinkedIn. You can follow Groundworks, you can follow Line Circuits. We're active on all social media. Follow us to stay connected for the rest of the workshops. Thank you, guys.
This is pretty useful because some of the references which we really
Yeah, please take it with you. Take it with you. Yeah, keep it.
I take 1 minute.